Hello, welcome first attendants on our event. We will wait a moment for other people. Okay, I see that number of people doesn't change for this moment, so I think that most of people who were registered and interested in our presentation and our training are already logged in. I will start from agenda, then I go to the very short survey about how do you find your skills related to cloud. Then we will go to the presentation to show technical abilities of CREODIAS and CloudFerro cloud, and then we go to the technical part with online training. I will show you some basic tasks related to using cloud. Let's go to the agenda. We have first I will describe you what is CREODIAS and CloudFerro company. Then I will go through presentation about our resources like virtual machines, volumes, etc. Then, as I mentioned, it would be live demo where I show how to create virtual machines, how to access it remotely. I will show you how to register at CREODIAS. And after everything, we will time for short Q and answer, query and answer session. So first, what is CREODIAS? CREODIAS is a platform, part of Copernicus system, Copernicus data space ecosystem, provided to give users access to Earth observation data. The idea of is to give people free access to Earth observations on data and possibility to use infrastructure with this access to data. So it's important in CREODIAS that you don't have to pay for the satellite images, but you only pay for the cloud infrastructures necessary to process it. Data is available in the CloudFerro CREODIAS hosted on the CloudFerro cloud and via dedicated fast network inside cloud. As I mentioned, CREODIAS is hosted on the CloudFerro infrastructure. We are a European company, completely independent to the other entities. The company has the location in Poland and is data centers in Poland and Germany, and some remote data centers for the other projects placed in the Finland, Spain, and Italy. So now we go to the technical part about cloud resources. First, I will talk about the data centers. As you know, in fact, cloud is somebody's servers placed in the big data centers around, typically around the biggest cities, near to the cities like Warsaw, Frankfurt, etc. Now we operate 4 data centers, 3 placed in 2 locations in Warsaw. So we have WAF 3.1 and 3.2 in one data center in Warsaw, and WAF 4.1 in the second location on the Warsaw border. Then we have the data center in Frankfurt, and we are building a new Polish data center in Łódź. It's a city placed about 100 kilometers from Warsaw to the south. To provide these infrastructures to you, we need a dedicated tool. In case of our infrastructure, it's an OpenStack. It's an open source project with decent history. It's a tool developed to manage virtual machines, manage virtual network, to provide all the resources, to separate users, etc. It has the access through the access to the OpenStack is possible through GUI. This GUI is named Horizon, and also it's available through the application interface. So you can use the OpenStack through the command line. You can use infrastructure as a code provisioning tools like Terraform or Pulumi, or even use the direct provisioning from the application or written in languages like Python or Go and other, because there are some dedicated SDKs. The most important resource in the cloud is a compute. It means virtual machine. It's a virtual computer simulated on a bigger server. And in fact, you can use this simulated computer as any other remotely available computer, but with the advantage that you don't have to manage hardware. In fact, you have to only manage and do administration for the operating system of this machine, but you don't have to install operating system in most cases. As I mentioned on the previous slide, those virtual machines, those instances, are part of bigger servers, and we provide such dedicated configurations named flavors in the OpenStack, and such flavor is just the set of parameters like a number of cores available, of CPU cores available for the user, type of processor used in the physical compute below the virtual machine, amount of the memory, size of the system disk, or type of system disk connected. And you can see that, for example, on the WAF 3.2 cloud, we provide the general purpose flavors Earth observation 1 and 2 based on Intel and AMD processors. We provide some flavors with the high memory amount, and we provide also GPU flavors. We have compute suites L40S NVIDIA cards and H100 cards. To run virtual machine, you have to use the operating system. We provide ready images, ready operating system to run systems to run on the virtual machines. That are most typical and most used Linux distributions like Ubuntu, Rocky Linux, Alma Linux, or CentOS. Or we provide for some data centers, additionally, we provide the Windows Server flavors and images. For Ubuntu, we additionally prepare by ourselves images with NVIDIA drivers and even with set of AI tools like TensorFlow, etc. So you can use just select such image and create virtual machine. I show you this in the moment. If you have some more specific related needs, like related with geospatial data, we provide some images with ArcGIS, Sen4Cap, or for security reason, we provide the image of OPN Sense operating system for the security and firewall and VPN. But there is a case that maybe this amount of images would be not insufficient for you, and you want to, for example, use some other operating system like Arch Linux. That is on the list. You have the still possibility to do this. You have to upload your image to cloud and install operating system, and with proper commands and task, you can prepare your own image that can be run as other images to create virtual machines. Also, it's possible to migrate, for example, from VMware. There are dedicated tools and support for images. For many cases, you want to install some technological stack for your application or virtual machine, and you don't have to do this manually. If you use the Linux systems, most Linux support solution cloud named CloudInit. CloudInit it's a way of running virtual machine that in this way that machine, when it starts, it gets from the dedicated network endpoint configuration file and configuration scripts and execute all this. And CloudInit it's a YAML file with information about the packages that should be installed, users to be created, etc. And you can provide this through GUI, like a text file attached to the virtual machine, also through all tools that I mentioned, command line and automatic provisioning. If you create virtual machine, then you have your compute, but usually you need some additional storage. In CloudFerro Cloud and CREODIAS, we provide you two types of storage. Block storage, it's a simulation of the disk available through the network, and backend for it can be on rotating mechanical disk as a solid state drives. Also, we provide the object storage. It's a solution where storage is available through HTTPS interface through the network and can be mounted or used directly from applications. Each virtual machine that is created in our cloud can have two types of can have system disk on the two types of storage. One is mentioned before, block storage, that it's available via network from the dedicated cluster and with the SSD hardware. Or there are flavors for specific usage where you need very high performance of the local disk. In this case, you can create virtual machines with the NVMe local disk from the compute. So it's the fastest option for creating fastest, the biggest performance for the virtual machine. They will have the fastest disk. Generally, all storage that we provide has other open source solution behind. It's a Ceph cluster. Ceph cluster is a solution that provides the high performance and redundancy. Data is from all devices that we provide, like a block storage on HDD or SSD or object storage, in fact, is a part of this cluster where data is divided into smaller parts called shards, and then those shards are spread across a big number of the servers and with big number of the disks inside. So in this way, cluster provide the redundancy compatible to the write disks in the single server, but more reliable. Other service that we provide in cloud is load balancer. It's a service allowing to spread the network traffic coming to single endpoint to single IP address to many servers behind, and easier scale our application or our calculations. So if you will need such tool, you can read about it and decide to use in our cloud. We also provide the important thing as a firewall functionality. In OpenStack, there is an integrated solution based in the networking. It's a security groups that are you can set for single ports or for the entire virtual machines, and you in such security groups, in their rules, you say in which direction traffic is possible, from which network class to which machines, and on which ports. And this solution have no additional cost. If you need something more advanced, you can of course use OPN Sense image that I mentioned before, and set up a firewall, VPN, etc. Things on this image. And in this case, you pay only for the instance running this operating system. For more advanced users wanting do calculation in the Kubernetes cluster, we provide the service OpenStack Magnum. This service allow to create Kubernetes clusters up to Kubernetes version 1.32 in this moment. You can create clusters from dedicated templates, as create clusters from your templates. In this cluster, you can use most of the flavors available in our cloud, including GPU flavors also. Important thing about CREODIAS is that it's wide documented. You can access our documentation on the addresses like docs CloudFerro.com or docs CREODIAS EU. And here you can find groups of documentation related to provisioning of virtual machines using volumes, using Kubernetes, or using networking in OpenStack. So most of the tasks that you have to do is described in details in this documentation. Now I will go to the practical live demo. On this demo, I will show you process of creation of user, how to register new user, how to ask about the provisioning resources, projects, and then how to provision virtual machine and access it from Linux through SSH. So now I switch to the sharing my screen. And now I switch to CREODIAS page. You can see that we have the login and sign up buttons. Login is for if you have already account, and sign up is to create new account. So I go to the create account. You see that we have to provide the email, our personal data, some information about our country, etc. To make it faster, I prepared already some data to provide. I confirm the agreements and go to create account. So we before we start, we have to configure the two-factor authentication. So I log in with credentials that I prepared. Click sign in, and you see that we have to scan on configure the two-factor authentication. In most of cases, you will scan with your phone with the application like Google Authenticator. I will do other thing because I'm using one password application. So I will create one-time password for this. it's expired probably. So yes, oh, no, I have some issue. Maybe I improperly copied the secret. Okay, so probably I copied improperly secret, and then I go to the email, and I have the email address verification, and you see I'm already logged in. To use the cloud, we have to create organization or join to some other organization that exist. In this case, I create new one. I copy this email. It's just for the technical purposes. I create just based on the email. In your case, you provide your real data. You see that it asks for the VAT number, and I skip it because it's test account. But for real usage, you have to remember to have this your VAT ID prepared. So now you can see that we have the ready account and ready organization. If I go to the cloud projects wallets, you can see that I see the all regions, but I have no button to activate it. It's because if I go to the wallets, I have a wallet, empty wallet. So in your case, if you will be accessing cloud, you have two options. One is go to the tickets and ask our support for some starting free credits, and after verification they will be given, and then after the you can purchase via some contract with the paper, for example, for pay-per-use credits, or if you have the fixed term contract, it means that you pay constant amount per each month. Then you have to ask also with ticket to provision for you project in OpenStack by our support. So now my colleague David, who helped me with this webinar, is adding in meantime the credits for this account. So you can see that I have now 250 euros on the account, and when I go to the cloud project wallets, the activate button is available. So in this moment, you have to decide where to provide your resources. you can it would depend on the some factors. One factor can be distance to the data center. If you are from the Western Europe countries like Holland, like France, probably using the our Frankfurt data center would be better if you want fast connection. It's a little bit faster than to Warsaw, but for example, if you prefer to have the use the GPUs, then better would be access one of our Warsaw data center. So for this demonstration, I will choose our WAF32. So I press activate, and it takes about half, maybe 1 minute to create a project and prepare the access to the OpenStack. You see that project was created, and in a moment this progress will should finish, and then we will be ready to use cloud. And all these tasks that we are doing now, it's not yet OpenStack. It's our tenant management, user and organization management system, where all, okay, so we have the message account activated. So now we can go to the OpenStack. And to OpenStack, we go through this panel, management interfaces, and I go to the Warsaw Frankfurt Cloud panel. You see that new window is opened, and ask to choose the brand that we using to connect. We choose the CREODIAS, and we choose the cloud. And now we are redirected to OpenStack interface, and you can see that we have the information about our user, our project, and all the management menus on the left side. As you see, it's a nice thing with CREODIAS that the default project is automatically created. So when we go, for example, to the network, you can see that for such project is created a dedicated network, default router, everything is ready, so we don't have to worry about this. We can connect our virtual machines directly to this network, and they will get access to the internet. In case if we have want to manage some our infrastructure in multiple projects, we can create new projects in the identity. We have the section projects, and we can create new projects in OpenStack, but such projects would be created without default network and default router, so we will have to create them manually, but there are documentation for this if would be necessary. But we go again to the compute overview. I will tell you a few words about this panel. It's information about our quota. You can see that by default, there are some settings like 20 virtual machines, 20 maximum 20 cores, 50 gigabytes of RAM, etc. For most of the projects, processing, etc., this quota would be not sufficient. And to increase this quota, again, we have to go to tickets and create a ticket with information to our support that I have such contract signed with for the cloud computing. We need such according this contract we need quota for such amount of these resources. So it's easy task. Support solve this very shortly. So this is quota, and now we go to the core of our presentation technical part, the instances. I will create now a new instance. You can see that we have the empty list. I press the launch instance. I give the name webinar. Webinar. But before, maybe I do my one step back, because it would be better. It's a better solution. We go to the key pairs and we create key pair. Key pair is a set of cryptographic keys, asymmetric cryptography, used to access virtual machine through a secure shell protocol. And of course, we can create this key pair during creation of virtual machine, but generally the doing this separately is a better practice. So I click create key pair. I provided the name also webinar. Webinar demo. I choose the SSHK and I click create. And you can see that the webinar demo PMEM file was created and downloaded. And here is inside there is a private key that we will use in the moment later. So, to the virtual machines would be injected the public key to decrypt the connection. So I return to the instances. I press the launch instance and webinar VM. We can give some additional data like a description. We can create multiple virtual machines from the same pattern. I go to the source and I choose in this place operating system. I do this with Ubuntu. You can see that we can filter flavors. So I choose the Ubuntu, the latest long-term support Ubuntu, and now it's a moment for the choosing medium. Choose the flavor. I choose some medium flavor. For example, let's choose EO2A. So it's a flavor based on the AMD processor, and for example, I choose such one. Then we go to the networks, and here is an important moment. You can see that we have two networks available. One is our default project network, so we assign it as a first network to our virtual machine. And you can see that we have EO data. This is this dedicated network to access, to fast access to Earth observation images. So if we want to use it, most of you will be interested with this. So we add this network as a second. We have some other options, network ports. It's a special option if we have to connect some other networks in the specific way, not automatically, but by selecting some already existing ports. So for this configuration, we can skip it. Security groups, we have to choose this allow ping SSH group, because without it we will not be able to access our virtual machine. And this is very important step. If we have only one key pair, is done automatically. Our SSH public key was automatically chosen. Here is a configuration. It's this what I told about Cloud Init. If we want to provide some script to be executed during the first startup of virtual machine, then we can put here the script, or put YAML with the structure according to the Cloud Init documentation. We can do this in this moment. So we have some other steps, but they are most advanced, so we can skip them and in this moment launch instance. You see a message that the creation was scheduled, and you can see now that OpenStack is building and spawning virtual machine. It's a small flavor, so its creation is not long. If for some flavors, especially this with the local storage, you should expect some longer time, but most machines are created, you see, in below 1 minute. So you can see that now we have the virtual machine that has EO data address, IP address, and we have the local address for our default network. But to access it remotely, we have to assign floating IP public address. So I click associate floating IP. And when we open this list, we see that no floating address is allocated yet, because it's completely new project. So I click plus. I don't change anything. I choose that just default external pool and click allocate IP. You see that some random address from our public pool for the cloud was chosen. I click associate. And you can see that we have it assigned to our interface for the default network. So we can, in this moment, we can test connection and connect from Linux. I go to the terminal, and I will edit SSH, prepare SSH public key. So I will do vim SSH. It's a hidden folder to keep the SSH configuration and keys. Webinar demo. And I copy content of this private key here. And most people will now try to connect, do SSH identity SSH webinar demo, but it wouldn't work, because if we created ordinary file, it has wrong access rights. We have to change the access rights to this file to be only read by the user who is owner. So we have to do first change mode order and group -read for this SSH webinar demo file. Okay, typing error. So we have the this modified. So now we can use this and it's important, it's typical for our cloud that default user for all virtual machines is EO user. And then add, and we go to the OpenStack and we copy this public IP. We accept the new fingerprint of this virtual machine, and you can see we are already logged into our machine. We can start to work with this. As I mentioned, for many, especially data-related projects, the default size of the system disk is not enough, so we should use the attach the dedicated volume, like attaching disk to the physical computer. So we go to the volumes. First, one thing before, to not forget it, you remember that we connected EO data network to this machine. You can see that it's here. So we can check this with the command IP all interfaces. IP again typo, and you see that we have the Ethernet 0. It's our connection to the internet, and we have the dedicated network, and you can see how easy is access, default access to EO data, because it's when we added this network, then our provisioner automatically mount the EO data through using S3FS tool. So when we go to the we list the content of the of the root directory, you can see that there is already EO data folder, and if we list the disk df, you can see that there is a S3FS like for the EO data, and when we ls EO data, it takes a moment, and you can see that we already see the folders, directories for the each satellite type that is in our repository. So you can, if you know exactly the structure of the for each this, then you can list the path for each of them. So you can see the access to EO data is already configured. You can use it like ordinary file system with the disk. And now we return to the volumes. I go to the volumes. You can see again empty project, so I create volume. Webinar volume. Empty, just we create empty volume. I choose the SS day as it's faster, and I put the size of 16 gigabytes. And by the way, you can see the how much of quota are you using now. I create it. It's take a moment. Okay, volume is ready. So I go to the manage attachments, select this, and you see that this volume is not attached. There is an option to select instance. I choose the one that we have, and we choose attach. I return to the terminal, and when I execute command lsbl, okay, it's a list block devices, you can see that we have SDB without partition. So we have, if we are using block devices, we in fact have to create partition and file system by ourselves. It's documented in our CREODIAS documentation, and I go through those steps manually. First thing, we have to install fdisk program or gdisk. You should, in most cases, prefer use to gdisk because it allows to create partition on the volumes greater than 2 terabytes, and I expect that many of you possible use such big volumes. So it's Ubuntu, so I execute sudo apt install gdisk and sudo gdisk and name of this device here. So it's a dev SDB. And you see that it's empty disk. When we print, there is no partition. Creation is true and new command. Default number, default first sector, default last. We use the entire disk. We are on the Linux, so we leave default file system code for the Linux, and we write. It takes moment and it's ready. So if we repeat our command, you can see that you have the SDB1 partition ready. But you have to create file system. So you have to use the mkfs ext4 on device dev SDB1 and add the sudo. Okay, its file system is ready. Please notice one thing, that we have the only 16 gigabytes, so it took milliseconds. If you will have the big partition, probably it can be longer. So you should be ready for this. Now we have to mount this file system to our disk. So we go to the typical cd mnt. We have the empty directory where we should mount. So we create dedicated directory. So we do sudo mkdir volume. We have to give usually not only root, but for example EO user or other users use these volumes, so we have to do sudo let's change own EO user the volume. And then we can proceed with the rest of the mounting configuration. Of course, we are interested in if we restart this machine to have it mounted again. So I will do sudo vim etc. It's a configuration Linux folder, fstab. Sudo apt install vim. I prefer vim, but default is nano on Ubuntu. Okay. I copy this line, put it here, and here I put such information. First, I put the div sdb1, it's our new partition, mnt volume, and other options like this. Save this and sudo mount mnt volume. You see, sometimes you will get the information about need to do this command. And then, okay, we mount, check the mount. You will see it's mounted. So we go to the volume ls. You see that we have already lost plus found directory. It means that we have accessing the real file system in Linux, and we can try to access the by doing touch test file, but it will not work because we will get the permission denied. And the reason is that we still there is a need to again get rights to already mounted volume. So we have to, and we go to the history. On, and now we go to the cd volume, do, it would be fine. And now we have everything configured. You have the working virtual machine with attached configured volume, and additionally you can see that you can easily access Earth observation data. We plan an additional technical webinars. In the next webinars, we will go to tasks like using object storage, some more advanced things related using cloud, like a creation of the completely new project, using configuration of the network security group. So if you will be interested in more advanced using CREODIAS, then please wait for the new announcement. So thank you. Now I am leaving. The event would be few minutes I'm still active. My colleagues finish technical tasks related to the recording and etc. And that's all. So thank you. Goodbye.